In this example, we rewrite the square root as a power. So we're going from 1 to 0 as our limits of 9x squared minus 12 times x cubed minus 4x plus 4. And we replace the square root with a power of a half. Then we follow our standard procedure. We let f of x equal the larger function. So it's x cubed minus 4x plus 4. And we let g at x equal to the shorter function, which is 9x squared minus 12. We get the first derivative of f at x. So that gives us 3x squared minus 4. We then work out a, where a is, you have x squared in both g at x and the first derivative of x, f prime x. So you're going to divide the coefficient of x squared in g at x, which is the 9, by the coefficient of x squared in f prime x. So that gives us 9 divided by 3, which is 3. And then the question is a times the first derivative equal to the second function in the product, g at x, is a times f prime x equal to g at x. So that's saying is 3 times 3x squared minus 4, and that gives us 9x squared minus 12. And yes, that is equal to g at x. So the answer is yes. So that means we can use our rule. So we'll write out the rule again. The integral of a times the first derivative of f at x times f at x to the power of n times dx is equal to a times f at x to the power of n plus 1. So you raise that power by 1 and you divide by the raised power. So if we come down here, we can implement that rule for our example here. So the integral of a, so a is 3 times 3x squared minus 4, that's our f at x, times x cubed minus 4x plus 4, and that is to the power of a half, times dx. So we have our a, f prime x, and f at x to the power of n. So we go along here. So we multiply by the a, we get our f at x, which is x cubed. Oh, sorry, I made one mistake there. That should be minus 4x, x cubed minus 4x plus 4. And that is to the power of 3 over 2 when we raise that power, and we divide by the raised power. So we bring it out, and sorry, we're not doing a constant of integration there. We have definite integrals here. So what we do is we're bringing that from the upper limit, which is 1, to the lower limit, which is 0. And I can put those limits over here. Sorry, that's 1 is red, and the green is 0. So if I followed similar procedure as before, I come along and I basically say that's equal to 3 times, and I invert this. So we have 2/3, and then I have x cubed minus 4x plus 4, and I split 3 over 2 into 3 times a half. Our limits are still going from 1 to 0. So then we're kind of lucky here. Our 3 is going to cancel with that 3. So we're left with equal to 2 times. And I open up a bracket and I open up a square root sign because we have the power to a half here. And then I have x cubed minus 4x plus 4. And I'm bringing that to the power of 3, which is what at the power I have here. That goes from 1 to 0. And then I'm able to put these values in. Plus 4 minus 4 times plus 4. And I can put the upper and lower values in. So it's 1 cubed minus 4 times 1 plus 4. And this is minus 0 cubed minus 4 times 0 plus 4. And sorry, I left out the cube, so all of this has to be cubed, and of course everything in here has to be cubed. So then that gives me 2 times the square root of, and you can see in here, that's going to be 1 minus 4 plus 4. So you can see I'm going to be just left with a 1 in there. And here what I have is 0 plus 0 plus 4 cubed. So if I keep going with this, that gives me 2 times the square root of 1 cubed, which is going to give me 1, minus the square root of 4 cubed, and that's 64. And this gives me 2 times 1 minus 8, which is equal to 2 times minus 7. So it gives me a final answer here of minus 14. Okay, thank you for listening.